Hello, let's go on to section 2.3. So these are the shortcut rules for the derivatives. Last time we looked at the definition, the limit definition. So if you do the limit definition or you use these shortcut rules, the derivative the derivative answer, or f of f prime of x, will come out to be the same. Okay, so let's do an example. For any constant c, the derivative is 0. Okay. So if you're, no matter what your constant is, the derivative will always be 0. So for example, the derivative of the number 5 is 0, and the derivative of pi, where pi is a constant, is also 0. Okay. For any constant exponent, what you're going to do is, if you have x to the n, you're going to bring the n out front, okay, and then let's do this. You're going to bring the n out front, and then do this minus 1. So the exponent comes out front, and you do exponent minus 1. Okay. Whoops. Okay. So for example, so then you get nx to the n minus 1. Okay. So let's look at x to the 7th. Okay, so what you're going to do is bring the exponent out front and do minus 1. So you get 7x to the 6th. Let's do another example. X to the negative 2. Now that's like 1 over x squared. We write it with a negative exponent. So you're going to bring the negative 2 out front and subtract 1. So then we get negative 2 x to the negative 3. Okay. Let's look at root x. So the derivative of root x is like saying the derivative of x to the 1/2. So then you're going to do the same thing, bring the exponent out front, minus 1. So that's 1/2 x to the minus 1, which would be 1/2 minus 2/2, which is negative 1/2. Right here. Okay. So then that you can rewrite as, I'll rewrite it here, 1 over 2 root x. Okay. If you have a constant multiple, okay, where you're multiplying the constant to a function, you're going to bring the constant to the outside. So you have c times f of x, you take c out the outside, and the derivative of f of x, which we write as f prime of x. F prime of x. So for example, the derivative of 5x to the 7th, you're going to bring the 7 out front, right? So basically what we've done before, minus 1, right? Because now you're combining the rules. We're taking the exponent of an exponential, or a power, right? Something raised to a power. So the 7 comes out front, so we get 7 times 5. 7 times 5, x to the 6th. That's 35 x to the 6th. Okay. Let's look at the derivative of 3 root x. So that is 3 times x to the 1/2, and then you can bring the 1/2 out front. So we end up getting 1/2 times 3 x to the 1/2 minus 1, negative 1/2. So then this becomes 3 over 2 x to the negative 1/2, which is 3 over 2 root x. Okay. Now we can combine all of these together to do the sum and difference rule. Okay. Basically, you're taking the derivative of the first function, derivative of the second function, and adding them together. So if I had something like the derivative of 5x to the third plus pi x, let's do that one. What would the derivative of that be? So you bring the 3 out front. 3 times 5 gives me 15, x squared, and the derivative of pi times x. So this is like x to the 1, excuse me, this is like x to the 1. So you're going to bring the 1 out front, minus 1. So the 1 minus 1 gives you a 0, and x to the 0 is 1, so you're left with just pi. See that? When you bring the 1 out front, you do 1 minus 1, which becomes 0, x to the 0, this becomes pi x to the 0, which is pi times 1, which is really just pi. Okay? So that's how you would do that one. So any number, the derivative of any number times x is that number itself. So the derivative of any number, like c times, c times x is just c itself. Okay, you can add that there. Let's evaluate a derivative. So we want to find f prime of 2. So again, I'm going to bring the 3 out front, so that's 6x squared, minus, bring the 2 out front, 10x, and then the derivative of 7 is just 0. Okay? So again, we brought the 3 out front, minus 1, 2 out front, minus 1. Okay? And this is f prime of x. Sorry, we're just leaving it as x for now. When we plug in 2, we get 6 times 2 squared minus 10 times 2, which is 2 times 2 is 4, times 6 is 24, minus 20, which is 4. Okay. Oh, I forgot to mention here the notation. So you can write the derivative as d over dt of f of t, d over dw of w squared, which is what we've been using all along. Okay. This is another kind of notation. This is saying find the derivative of f with respect to x when x equals -1. Okay, so when f prime of x, again we bring the 4 out front, minus 1, you get 20x to the third. The derivative of 1 is a constant. Okay. Then we're plugging in -1 into the function, so you get 20 times 1 cubed, which is 20. Now, if this video is going a little fast for you, I recommend you stop it and try the exercises yourself. Make sure you can do the examples yourself, or you can also rewind it and play it back. Okay. So let's look at something called the marginal. Okay, the marginal cost is the derivative of the cost. Marginal revenue is derivative of revenue. Marginal profit is the derivative of the profit. Derivative we know is the slope of the tangent line. It is also the instantaneous rate of change. And now we know it as the marginal. Okay, the cost of producing one more item. So that's what the marginal is. Cost of producing one more item. Okay. So the Pocket Easy C is a mini or keychain flashlight based on LED technology. The cost function is C of x, let me write this down, is 8 times the 4th root of x cubed plus 300. So we have to convert this to exponents. Find the marginal cost function of this cost function, so that is the derivative, that is c prime of x. Okay. Again, we're going to bring the 3/4 out front, so you get 3/4 times, and then we have to plug in, no, we have to bring the 3/4 out front, then we do 8x to the 3/4 minus 1, which is minus 1/4. Okay, and then the 8 over 4 gives you 2, and then you get 6. Oops. 6x to the minus 1/4, and the derivative of 300 is just 300. So this becomes 6 over, let me make this one bigger. Yes, my computer is not optimal. I'm trying to switch to a new system here. So we get 6 over the 4th root over the 4th, oh dear, 4th root of x. Okay. It says find the marginal cost when 81 pocket EZCs have been produced and interpret your answer. So now we need to find the marginal cost when 81 pocket calculators have been produced. So we simply take 81, plug it into the function, and let's see, 3 times 3 is 9, and 3 times 3 is 9, right? 9 times 9 gives me 81. So I know that the 4th root of 81 is 3. So we get 6 over 3, which is 2. Okay. So the marginal cost is the cost to produce one more item. It's going to be $2. Okay. Let's look at this example here. Media companies, they can buy multiple licenses for audio time, audio recording software at a total cost of approximately C of x, which is 168 x to the 6 dollars for x licenses. Find the derivative of this cost function. Okay, so again we are going to take the derivative. So we get C of x is 168 x to the 5/6. And then we want the marginal cost, which is the derivative of the cost function. The 5/6 comes out front. You get 168 x to the 5/6 minus 1 is negative 1/6. Okay. And for that one you can use your calculator. Oops. 168 times 5 divided by 6. Okay, and we get 140 x to the minus 1/6, which we can also write as 140 over x to the 6th. Okay, so now they say find the derivative of this cost function at x equals 1. So this is the derivative at x equals 1. So you're going to plug 1 into the function and you get $140. So that's what it costs to produce the 141st item, the next item. Let's do the next one. C prime of 64, which is 140 over 6th root 64. Now we know 2 times 2. If you're not sure how to get these, 2 times 2 is 4, times 4 is 16, times 4 is 64. Okay, so the 6th root is 2. And we get $70. Oh, where did this 140 come from? I'm sorry, I made an error here. Let me fix this. The $140 is the cost to produce the second item. My apologies. This is what you want to look at. So at x equals 1, the marginal cost is the cost to produce the next item. Okay. For part B, it's $70 to produce the 65th item. Okay. It says use a calculator to find the actual cost of the 64th license by evaluating C of 64 minus C of 63. Is your answer close to the number $70 that you got in part B? Okay, So let me go to my calculator and put this in. So, oops, it's 168, so I'm going to go to y equals 168 x to the 5/6. Okay. To find the actual cost of the 64th item, right? So we're going to do C of 64 minus, whoops, C of 63. Okay. And when we do C of 64, we do, what's my calculator here? I'm going to use a table feature of this calculator. So you're going to go to second table, or second table set rather, second window, and you want the independent to be ask. And you go to second table, and I want to find the amount for 63 and 64. So it's 5305.9, which is roughly 5306. And then the price went up to 5376. Right, when we subtract them, we get close to 60. Okay, this is actually 5305.9. So let me make that. Okay. So this is all about taking derivatives. Now, when I teach this class face to face, we actually go through and we do these examples, or these examples in groups, and I call people to the board, or we share our answers, and then the remainder of the class is devoted to active learning problems. So the lectures are actually short, but the active learning problems is where the real learning takes place, because you get to apply your knowledge. So if you don't do the active learning problems, that's fine, as long as you do the homework, okay? So let me know if you have any questions. Feel free to stop by. I have office hours. They're listed in the syllabus. If you don't know, office hours are just walk-in tutoring hours. I'll be here at that time, from Monday through Thursday, 2 to 3:15, and you can stop by and ask questions, okay? Thank you for watching.